pretend like this is where we started here. Here we go. Okay. So if you're watching this at home. So now this part. Again, I want a formula, not with all this summation stuff. I just want an N formula. So, side note here, if I were to expand this, wouldn't this be 4n over n to the fourth, and when one goes in for I, it would be 1 cubed. Then I'd have 4 over n to the fourth, and when 2 goes in for I, I'd have 2 cubed, and so on, yeah?
Yes.
So I think you'll agree that every term is going to have a greatest common factor of 4n to the fourth, and it's really just multiplied by the I cubed. So there's no reason I can't just take out the 4 over n to the fourth out front and just focus on what's this, oops, infinite, what's the sum of the I cubes? Because the counter's all about I anyway, not n. We kind of do that with limits, right? I mean, if the limit doesn't pertain to that function, we can pull that number out front. You follow? So by the same token, what might we do to the second expression? Pull a 2 over n and sorry, 2 out and a 4 over n squared out and focus on just the i's. Again, I'm just gonna. It's such a habit, I can't even break it. All right, you done? Okay. Now, if only I knew what 1 cubed plus 2 cubed plus 3 cubed plus 4 cubed was. What does that equal? Well, it would kind of depend on where you ended, but is there some kind of formula for adding a bunch of cubes? Like that. All right. So this is equivalent to 4 over n to the fourth is still there, but those sum of cubes is the same as n times n plus 1 all squared over 4. That formula finds the sum of cubes ending at some nth number. Please, I beg you, stop me if I'm losing you, if you don't get what I'm doing. Please ask. This is heavy stuff, you know? All right, are we cool? All right. So what do you reckon we're going to do for the second sum or add in? Yeah, we'll use that same formula of, we keep this outside stuff, 2 over 4, 2 times 4 over n quantity squared, but in place of the sum of a bunch of growing numbers, 1 plus 2 plus 3, we use, which of the formulas, 1, 2, 3, or 4? Second one. So that we call that 2, I think. All right. So, boom. Now that surely could clean up, but as far as answering the question, did we find a formula without summation notation? Yeah. All right. Now we could clean that up, and we will clean that up, and we'll use end behavior in a second. But as far as the question goes, we're done. Cool. Okay. So then, preferably you would be doing this right after we had done one, so it's fresh in your mind. But you feel like you could give this a go, or should we walk through this together also? Okay. Here we go. That's the old spirit. Love that. When I say that to pre-calculus, they all say, "Do it, Gordon." Can doers. I love that. I'll work a little behind you so you can look up here in a second, see if you're on the right track. How are we doing? Okay, so while you're finishing, let me explain. First of all, that step where I was doing expanded form, where I factor out the base, but inside I show f at this plus f at that, that's optional. If that helps you, great, go for it. If you want to jump straight to summation notation, it'll save you some time, which I'm happy for you to save the time, okay? Is that necessary, or can I go straight to here without losing it? Does this help you at all? You do this? Give me a yes or a no. Okay, cool. If it helps you, then I'll be happy to put that in. But that's where I next went. Then I put in the function. The next thing, you're by the bookish, but I definitely would encourage you to try and shorten up how many steps. So, for example, I'm going to have one summation that has a 3 over n outside and a bunch of 1s. And then I'm going to have another summation that has 3 over n and 2 more 3 over n's, so the cube of 3 over n before the sum of a bunch of what's? I squared. Okay, now if you did that in multiple steps, great. If that's what it takes for you to get it right, great, do that. But if you can make that jump, then you'll save yourself some time. Are you with me where I'm at right now, or do I need to back up and show you where I got that? Okay. Okay. This one's kind of so simple, it's strange, but what's the sum of 1 plus 1 plus 1 plus n times? What's 1 n times? N times 1 or just n, right? So 3 over n times n, which obviously those we drop out. And 3 over n quantity cubed is cool. And using the formula, the sum of I squareds is n times n plus 1 times. Okay, I'll pause and say, those formulas do not need to be memorized. I am not big on memorization. I will always give you those formulas at the top of the test. You're not going to memorize those two. Okay, understood? All right, did I accomplish the goal of getting this without summation notation? Okay, so if I plugged in n equal 2, what does it mean? What does it give me? It gives me an estimate of the area under the curve in this region based using 2 rectangles, and it would be a decent estimate. If I plugged in n equal 5, then that would be an estimate of the area under the curve from 0 to 3 using 5 rectangles, and it would be a better estimate because the error region, which is up here, would be lesser, yeah? So what would be the best case if I let the number of rectangles increase without bound and go to infinity, yeah? So that's the next goal. Actually, that's not the next goal. Sorry. The next goal is to write one where it's not starting at 0. Sorry, I just one step ahead of myself. These then feel like the exact same question, but they're a little harder when they don't start at 0. So this, if you're iffy on this, you might go expanded form. Again, that's optional. But it is confusing when it doesn't start at 0. Let's see if we can go to summation notation right away. So again, every estimate is the idea of a delta x times the heights at different points. The delta x is pretty straightforward still. What's the delta x? 2 over n. The total region width, 4 minus 2 is 2 wide, and we're going to divide it in inches. All right. The harder part is the height at. Think visually here. If I start at 2 and I go over a 2 over n to get to my first x, then what's the first x? 2 plus a single 4 over n. And what's the second x? 2 plus 2 4 over n's, right? So generally, isn't the height always, yes? Oh, I'm writing 4 over n. Yes, I'm sorry. No wonder you're confused. I was thinking people are confused. I thought I was doing so well. Yes, sorry, the delta x is 2 over n. So I misspoke, sorry. Do you agree with the x1 being 2 plus 1, 2 over n? And x2 being 2 plus 1, 2, 2 over n?
Yes.
Okay, I misspoke. Thank you. So f at, generally speaking, it's always f at 2 plus I 2 over n's. All right, so when it starts at someplace besides 0, it's going to be the starting point plus so many delta x's, okay? Starting with a 1 to n because it's right-hand rectangles. That's goes to right-hand rectangles. And so let's get more specific. What do I typically do now after that step? Okay, I want to extract all the i's, but first I need to put in the function, yeah? So the function is x cubed, so I need to say this is 2 plus I times 2 over n cubed. Is that just 2 cubed plus I cubed, 2 over n cubed, or is that not how expanding a cube works?
It does not.
That is not how expanding a cube works. It is to my chagrin that we need to know binomial expansion. And what is a plus b quantity cubed expanded? A cubed plus 3a squared b plus 3ab squared plus b cubed. With that said then, a is 2, so the first thing is a cubed, which is 2 cubed, or 8, whichever you prefer. The next one is 3a squared b. So that's 3 times 4 times, what's b? What's b? I times 2 over n, okay? Plus 3, what's a? 2, what's b squared? I times 2 over n all squared, and b cubed is I times 2 over n all cubed. This is as gross as ever cubed, so, and we're doing it. So it'll be a little cleaner. Okay, 2 over n. All right, are you ready to blow this baby up into separate summations? So the first one is I would have a 2 over n times the sum of a bunch of 8's. And then I'd have next? What is all the stuff I could pull out when I go here? I can pull out a 12 and how many 2 over n's? Squared, are you with me? Times the sum of a bunch of i's. And then here, what could I pull out? 6 plus 6, and how many 2 over n's? 1 there and 2 there, so 3 times the sum of a bunch of I squareds. And then lastly, what can I pull out? 2 over n quantity to the 4th times the sum of a bunch of I cubes. We're getting there. We're getting there. We're almost done. One more step. Okay, so replacing now each summation with the formula 2 over n times 8n. 8n times is a total sum of 8n. Then 12 times 2 over n quantity squared times what formula for the sum of a bunch of first degree numbers? plus 1 over 2 plus 6 times 2 over n quantity cubed times the formula for a bunch of squares. N times n plus 1 times 2n plus 1 all over 6. And then 2n to the fourth times the sum of a bunch of cubes. N times n plus 1, that whole squared over 4. If I remember right. I think that was it. Cool? Okay. You try a little easier one. This one's only a square, not a cube, so it won't be as bad. Try that one. Did you get something like that? Or you're still working, or you're good to go. 2 over n times an n. 2 over n squared times 2 times the formula for I is n times n plus 1 over 2. And 2 over n cubed times the sum of squares. Let's call that A. Or area formula as a function of area. Okie dokie. Now, let's run it in for the touchdown. Let's get the exact area under the curve using infinite right-hand rectangles by taking the limit. What happens as you take the limit? It's mostly all the same previous work to get a function a depending on how many rectangles, but then saying what happens as the number of rectangles goes to infinity in your formula. If you get infinitely many more rectangles, what is your area formula approach? You follow? Okay, so the first thing is all that work we've been doing so far. I'm going to go straight to summation notation and establish the delta x and the f at which value. What's delta x? 2 over n, and f at, am I starting at 0 or some other number? It's just starting at 0, so instead of starting number plus deltas, it's just deltas. So what's inside the function? 2 over n, I times, or I 2 over n's. Do you understand where that's coming from? Because if you miss that step, then you're going to do a ton of steps wrong, because you built on a bad starting point. All right, cool. From 1 to n, because it's right-hand rectangles. Now what do I do? Plug in the function. So 1 plus 3 blank squared, and in each blank goes 2 over n I times. All right, then what do? Yeah, you separate it, blow it up, blow it up. So I could have one sum of what out front, what inside. I feel like I only need two sums. So what's the first sum? 2 over n times the sum of a bunch of ones. And then what outside of the next one? 2 over n cubed and 3, and inside is sum of a bunch of I squared. You follow me? Okay. Then what do? So I'm going to plug in the formulas, the appropriate formulas. What's the sum of a bunch of ones? N ones adds to n. And what's the sum of a bunch of I squareds? N times n plus 1 times 2n plus 1 all over 6. That's the area formula based on any number of n's, yeah? Okay, now here's where I am going to do a little less writing. I feel like writing that is, you can write it if you want all day long, but I'm just going to look at that. I'm just going to call my limit a sub. Okay, it's been clearly established in my work what that stands for. Nobody should be confused what a sub n stands for, but it keeps me from having to write it. Let's talk n behavior. Wouldn't you agree that when we talk infinite limits, we're talking n behavior, yeah? As you add infinitely many n's, what does that approach? 2. Now, this one I kind of have to think my way through. Power-wise, what's the greatest n power in the top? N to the third, and the bottom n cubed. And so do you agree it's equal powers, which means n behavior is the ratio of the coefficients. Okay? So let's gather all the coefficients. In the top here, what will it be? 8 and 3 and 2. And in the denominator, what is it? 6. You see where I'm coming from there? Any questions of where I'm getting those numbers? Okay? So what does that sum to? That sums to 8, I agree, and therefore all comes to 10. Gosh, that's so much work. If only I had a way to check. I bet you. Check. This is where you see, oh, it's so stupid. Why could he do this all the time? It's all good. We'll get there. What's the antiderivative of 1? X, and the antiderivative of 3x squared? X cubed from 0 to 2. When I put in 2, I get 2 plus 8 minus zeros, and that is check. Why don't we just do that before? So where do you think this comes from? What do you think infinitely many delta x's is? Don't you agree that when you do this over and over, delta x gets smaller and smaller? And what do you call an infinitely small delta x? Yeah, you call it dx. And what is the function each time? Well, yeah, there it is right there. Now this is the same as infinite Greek s. That's a Roman s, and it stands for infinite Greek s. It stands for sum. Okay? So that definite integral is not just looking cool. It comes from this. And there is no b without a. All right. Is there something past that? Oh, there's one for you to try. Normally I would say, let's just do the one on the homework, but really you need all the practice you can do on it. So would you do this? Yes. Just to mess with you. Thank you for stopping me before I ripped before. That would have really made me mad. Uh-oh. Oh. Oh, I can't quite read that. Well, do we win? Okay. You should know if you did it right by fundamental theorem, which is to say a definite integral. Yes?
Can you just explain the second term of 27?
Here?
Yeah.
Yes. Okay. So first thing that went through my mind is the powers work out. In terms of n behavior, remember n behavior, I need to look at how the n's relate. Do you agree it's n cubed on top and n cubed on bottom? So that tells me just like when I do something like this, 2x cubed plus 5 over 3 minus 4x cubed, do you agree that when we did M behavior there, once we established that these are the same powers, then we just say, as these go forever, these mean less and less, the cubes basically cancel, and it's the ratio of the coefficients. That's what I'm doing here. I'm looking through for all the numerical components in this term. So I got a 3 cubed there. That's where that 27 came from. And then I also had a 2 over there. That's where that came from. And the denominator, all I had was 6. Does that make sense? So it's the numerical parts in the formulas. Okay. Good question. Other questions? All right. We good? Do you feel like you can do this? All right. There is one on the homework, at least I think, where you don't start at 0. I think at least I didn't make it a cube. Well, maybe I did. I don't know. I am that mean. I don't know. But you'll get one where you didn't start at 0, and I think you'll be fine because you're brilliant. What's this? I don't know what this is. Oh, this is the homework. So you're fine to finish. You should be good on the last stage of review 10 now, and let's do tomorrow. We clear? Okay, cool. Questions on review 9? I said review 9 is due today. Actually, I don't know if you still have review 8, how they just handed it back. But some of you have X's on the back. And I would like to communicate why. Uh-oh. What happened? Oh, it's up here now. That's so strange. I don't like that. How do I get this out? Oh, okay. Oh, perfect. Okay. Sorry. I just need to post this in. Review 8. Recent. Open other documents. Okay. On the back side, top half. This is a point that I don't know if Ms. Cannon touched on this or not. It's a pretty gross problem, but again, I want to teach this at the highest levels so you're not at any disadvantage. So I'm looking at this problem. Are you with me? Okay. Now, the gotcha to this is not the interiors, which you all killed, okay? If it says relative mins and this is f prime, then you need to find where f prime goes negative to positive. I think you'll agree that that's at 1. So most of you people said there's a min at x equal 1 because f prime changes negative to positive, and that was great. I do not want you to change anything about that. What I want you to understand is this is a very different problem if they include the endpoints, because endpoints can be extrema if they include them. Let's consider this. At negative 4, right after that, the derivative is positive, yeah? So if the derivative is positive, what's the function doing up until negative 2? It's increasing. So up until negative 2, it needs to be increasing. Well, if I'm including that point, not an open circle, but a closed circle, isn't that a minimum? It is. And so that needs to be included also. There's also a min. This kind of goes to just saying it decent, all right? The phrasing is not as picky as interior points, where they are very picky. There's a min at the left endpoint, x equal negative 4, because f prime is positive afterwards. Okay, that would probably demonstrate most, at least for my professor. Are you with me? So let's talk about at x equals 7. Excuse me. At x equals 7, it's somewhere. I'll just put it there. I don't know. What was it doing before that? The derivative was positive, so the function was doing what up to then? Increasing. So what does that make the right endpoint 7? A max. And so besides the interior, did you have an interior max maybe at negative 2? Okay, which most of you had. There's also a max, a relative max, at the right endpoint x equals 7 because f prime is positive before. Understood? Okay, and this one they would be very picky on, but we'll get to fundamental theorems, so don't worry about C. That's just what I want to talk about. Now, questions on review 9? Yes?
12.
12, yes. I said there would be a derivative-y kind of quiz. I don't have my acting together enough to do it tomorrow, so Friday, a derivative quiz. It's not like test heavy, it's just a derivative quiz, okay? You said 12, Lindsay?
Yeah.
Okay, cool. The hard part of this was I was in one mindset for this. Oh, never mind, that's not something else. Okay, this was a humdinger. I pulled this from a textbook, and I stared at this a while myself before I saw it. So the first thing I tried was USA because it felt like that. The problem, and no doubt the problem you came up with is, that's great if the x isn't a numerator x, it's a denominator x. And so what do? So what do? Think, how can I clean it up and make my life easier first? What can you do to make your life easier first? Yes?
I put the x squared, I put the 2.
Beautiful. That is exactly what you should do. All right, now that said, now it's USA. Because if you let u equal, what will you let u equal? Anybody?
Natural log of x.
Yeah, if u is natural log of x, then now du is cool. And so it looks like 2u du, if I'm not mistaken. So u squared plus c. So at the end of the day, natural log. Now, you need to be very careful about those parentheses. That needs to be all in parentheses, because if you write it this way, that implies that the x is squared, not the whole is squared. So you would have to write that. Does that make sense? Okay, good question. What else? Anybody else? Any others? Did I put the key online? You probably didn't look, but I didn't tell you. The key's online. So, I did? Oh, I didn't tell you. Well, I'll tell you now. So, in 7th period, if you still have questions on this, you can look online 7th period and get it to me by the end of the day before you do, okay? Yes? I hope so. 19, yes. Okay, so I didn't actually include in my derivative applications a related rates example. And that's because Miss Cannon teaches related rates so well that people usually do it great. So 19, first of all, the big idea. So there's a conveyor belt, and it's got sand in it, and it's pouring down into a pile beneath, a cone-shaped pile. Okay? I should have said inverted cone-shaped pile. Let's talk about related rates. Typically, you identify what's given, kind of in a science way. When they say the sand pours in at a rate of 2 cubic meters per second, what is that in calculus? dV dt is. I would love for you to be intentional about the sign. A teacher will grade very carefully for, do you understand when the change is a positive one or a negative one, and such problems. So be intentional. The volume is increasing, so the rate of change is positive. The derivative should be positive, okay? Okay, now, you're also given, by the way, I think that the height is half the radius. That's also given. What do you want and when? You want the h dt when the volume is 100 pi, yeah? Okay, great. So, we agree that to get calculus on volume, I'll need a volume equation. What's the volume equation? 1/3 pi r squared h. Could I do calculus for 3 variables using the product rule and differentiating with respect to time? Sure. Is it easier to substitute in and get it down to 2 variables? Well, yeah. How can I get it down to 2 variables? Okay, so replace h with 1/2 r, and that would be true. would I rather keep H though? Why would I rather keep H? Now you want the HTT, so I feel like it would be better stuff for R. Isn't R 2H? So if you do that, it's pi over 3 times 2H quantity squared times H, or 4 pi over 3H cubed. Do you agree with that? Am I cool? I'm going kind of fast, and I make mistakes when I go fast. Can I get a yeah? Okay. All right, now I differentiate with respect to time. So what's the derivative with respect to time on both sides, but technically the right is what I'm focusing on. What's the derivative with respect to time on the right? 4 pi over 3 times, oh, you're already stepped ahead of me, I see what you're saying. The 3's go away, 4 pi h squared. Wait, d, okay, now chain rule, I took the derivative of the outside, but now the derivative of the inside. What's the derivative of the inside with respect to time? dH dt, okay. You're differentiating with respect to time, not with respect to h. So you need to be good with your chain rule. 4 pi h squared dH dt. So isn't dH dt dV dt, which is one thing, keep it together, divided by 4 pi h squared? Oui? All right. Now the instant. What's dV dt? 2, 4 pi. The only thing I need to overcome is what's h at the instant? Well, I know at the instant they talk about volume isn't volume 4/3 pi h cubed? And at the instant they ask about volume is 100 pi. Are you going okay? Is it going okay? I want to find what's the h at the instant they request. And the instant they request is giving me about volume. So I need to find what h is. So if I solve this, it would be 100 pi times the reciprocal, so 3 over 4 pi. So with a little whoosh, whoosh, I get the height cubed is 75. So the height is the cube root of 75. So there's my answer. The only thing left I have to put on is the units. What are the units? Change in height with time? Meters per second. Okay? Okay. Get this to me by the end of the day. Have a wonderful day.